Hello viewers, in today's session we are going to discuss an important problem from application of derivatives, that is increasing and decreasing functions. So here we have this problem where we are given a function f of x that is equal to sine square x, where x belongs to the interval, that is the open interval 0 comma pi. And here we have to find out the subintervals of 0 comma pi, where this function f of x is increasing or decreasing, right? So this problem is from increasing and decreasing functions, and we are given this function f of x where x belongs to the interval 0 comma pi, and we have to find the subintervals of this interval, that is 0 comma pi, where this function f of x is increasing or decreasing. So let us see how we can find out the subintervals using the concept of definition of increasing and decreasing functions, and the concept of derivative. So let us first quickly see the definition of increasing and decreasing functions in terms of derivatives. Suppose we are given a function, say y is equal to f of x, which is defined in some domain D, right? Now this function y is equal to f of x is said to be an increasing function if the derivative, that is f prime of x, is greater than 0 for all x belonging to this domain, that is D. And this function f of x is said to be a decreasing function if the derivative, that is f prime of x, is less than 0 for all x belonging to the domain D, right? So this is the definition of increasing and decreasing function in terms of derivatives. So a function f of x is said to be an increasing function if the slope is greater than 0, right? So f prime of x is greater than 0 for all x belonging to the domain, and the function is said to be decreasing function if the slope is less than 0, that is it is always negative for all x belonging to the domain D. So we'll apply this definition to this function to get the subintervals. So let us first find out the derivative of this function. So we have f prime of x is equal to d by dx of sine square x. Now the derivative of sine square x is simply 2 sine x, and then by chain rule the derivative of sine x is cosine x. So we have 2 sine x cos x, and 2 sine x cos x is simply sine 2x, that is the double angle formula for sine function, that is sine 2 theta is 2 sine theta cos theta, right? So the derivative, that is f prime of x, is equal to sine 2x, where x belongs to this interval, that is 0 to pi. So now the function f of x is said to be an increasing function if the derivative, that is the f prime of x, is greater than 0, right? So f prime of x is equal to sine 2x, so we have sine 2x greater than 0. So now we have this trigonometric inequality, right? Now see, this function f of x is said to be increasing function if the derivative is always going to be positive, that is greater than 0 for all x belonging to this interval, that is 0 to pi. Now f prime of x is sine 2x, so sine 2x should be greater than 0 for all x belonging to this interval, so that this function f of x is increasing function. So now from the sign convention of trigonometric functions in four quadrants, we know that in the first quadrant, all the six trigonometric functions are positive or greater than zero. So let us first write here first quadrant, second quadrant, third and fourth quadrant. Here we have 0, then we have pi by 2, then we have pi, and here we have 3 pi by 2, and here we have 2 pi, right? So now here we have sine 2x greater than 0, right? So it means sine 2x is positive, right? And from sign convention of trigonometric functions in four quadrants, we know that when the angle that is 2x, or in general if we have the function say sine theta, when theta belongs to the first quadrant or the second quadrant, then sine theta is positive or greater than 0. So it means when theta is greater than 0 but less than pi, then sine theta is greater than 0, and here we have sine 2x greater than 0. So it means we should have 2x. Here we have for theta we can write 2x. So 2x is greater than 0 but less than pi. Now if we divide throughout by 2, we have 0 over 2. Here we have 2x over 2, and here we have pi by 2, and here we have 0, here we have x, and here we have pi by 2. So when x is greater than 0 but less than pi by 2, then sine 2x is greater than 0, right? Or in other words, this function f of x is said to be increasing function when x belongs to this interval, that is 0 comma pi by 2. So this function f of x is said to be an increasing function when x belongs to this interval, that is 0 comma pi by 2. So now let us consider the case when this function f of x is a decreasing function. So from the definition of a decreasing function, the derivative f prime of x must be less than 0. So f prime of x is sine 2x. So sine 2x should be less than 0. So now again we'll take help of the sign convention of trigonometric function in four quadrants. Now we have already discussed that in the first and second quadrant the sine function is positive, right? And in the third and fourth quadrant the sine function is negative. So we can now write here when if we have say sine theta, then if theta is greater than pi but less than 2 pi, then we have in the, or we are in the third and fourth quadrant, right? And sine theta is negative in the third and fourth quadrant. So here sine 2x is less than 0. It means sine 2x is negative, right? And sine 2x is negative when 2x, here we can take theta is equal to 2x. So when 2x is greater than pi but less than 2 pi, it means 2x should be in the third quadrant or fourth quadrant. Now dividing throughout by 2, we have here pi by 2, 2x over 2, then we have 2 pi over 2. So we can now write here pi by 2, here we have x, and here we have pi, right? So when x belongs to this interval, that is x belonging to pi by 2 comma pi, then this function f of x is said to be decreasing function, right? So when sine 2x is less than 0, it implies that x should belong to this interval pi by 2 comma pi. So from this discussion, we have arrived at the conclusion that if we have here say 0, and here we have say a pi, and here we have pi by 2. So when x belongs to this interval, that is from 0 to pi by 2, then the function is said to be increasing function. And when x belongs to this interval, that is from pi by 2 to pi, that is pi by 2 to pi, then the function is said to be a decreasing function, right? So from 0 to pi by 2 the function is increasing, and from pi by 2 to pi the function is said to be decreasing function. So we have the sub intervals as 0 comma pi by 2 and pi by 2 comma pi. So in this interval the function is increasing, and in this interval the function is decreasing.